Hello and welcome to this video about concentration and solubility. We're going to look at concentration, solubility, and different types of solutions. When we talk about concentration, you know the terms concentrated and diluted. You know that those mean very imprecise, not quantitative measurements of how much solute is actually dissolved in a given amount of solvent. When we talk about concentration, we are talking about the amount of solute that's dissolved in a given amount of solvent, and the terms concentrated and diluted are not precise or quantitative measurements of that. One way to talk about concentration would be the percent of solute that would be dissolved in the solvent. You could talk about the milliliters of the solute dissolved in a solvent per milliliters of solvent. There are a lot of different ways to talk about that. You can see that this says 100% juice. This one says 42% juice. So if 42% of this drink is orange juice, how many milliliters of juice are in 250 milliliters of the drink? We could figure that out by saying 42% of 250 milliliters. That would be the same thing as saying 0.42 times 250 milliliters. And that would be 105 milliliters of this is actually orange juice. So, when we talk about the term solubility, what does that mean? And how is that different from concentration? When we talk about solubility, it is the maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. So if we try to dissolve more and more solute in a solvent, at some point it will reach its maximum and it can't hold anymore. There are different ways we can measure the amount of solute that a particular solvent might be able to dissolve at a given temperature, and those one way could be grams of solute per 100 grams of water, if we're talking about the solubility of these substances being dissolved in water. This is one way to quantify that. You can see that there's a wide variety of solubilities here. Gases have much lower solubility than the solids, and even within the solids, baking soda is not nearly as soluble as, say, table sugar. Let's think a little bit about solubility of these gases. You are familiar with this because you drink carbonated beverages, and it shows us the effects of pressure on the solubility of gases. When these carbonated beverages are bottled, they're bottled so the pressure inside the bottle is greater than the pressure outside the bottle. And that increases the amount of carbon dioxide that can be dissolved in the liquid. Here, these are little CO2 molecules in there. When you open the can here, the pressure inside of the bottle decreases and the carbon dioxide gas that's mixed into that soft drink escapes from the soft drink and it bubbles out. Temperature definitely affects solubility of gases. Warm versus cold. Which condition do you think causes more carbon dioxide to bubble out? Well, more carbon dioxide is going to bubble out of a warm soft drink than a cold soft drink. You probably realize that because if your can is sitting in the warm sunshine, it's probably going to go flat quicker. But another way to think of that is that you can increase the amount of gas that you're dissolving in the liquid when it's colder. This is called a solubility curve for each of these different ionic compounds, and a solubility curve is useful for determining how much solute of a substance will dissolve at a given temperature. Let's say, for example, let's look at potassium chloride right here. Here's the solubility curve for potassium chloride, and we can see that at 80 degrees Celsius right here, we are at about 50 grams of potassium chloride will dissolve in 100 grams of water and produce a completely saturated solution. In other words, that's the maximum amount that the water can hold. It can't hold any more than that at this temperature. So we've used these terms already throughout this video a little bit, saturated. And let's just clarify the terms for you. A saturated solution contains all the solute that it can hold at a given temperature. An unsaturated solution means I could put some more solute in there at a particular temperature. It hasn't reached the maximum that it can hold. There is something called a supersaturated solution, and you all know about these. They contain more solute than a saturated solution at the same temperature. A way to do that would be to heat your solvent up as you're dissolving your solute, and you can actually add more in, but it's an unstable solution with all that extra solute, and the excess solute is going to end up crystallizing and forming a solid. Advanced ideas. In general terms, solutions can be described as concentrated or dilute. Precise concentrations obviously are expressed in other terms, but can you think of other examples in which general versus precise terms could be used? Or what is molarity? What are the units of molarity? What does molarity measure? Or maybe you have other ideas. I look forward to seeing what you come up with, and we'll see you in class.